Hey guys, preparing for a competitive examination? Tell me one thing, is your affinity towards a subject directly proportional to a chapter that you are good at? Well then, I'm sure you are aware that your rank in that competitive exam is also directly proportional to the number of chapters that you are good at. And you want maximum number of chapters to be in the good zone. Yes or no? Well, how do you achieve that? At Vedantu, we all master teachers have created a special and a very unique course just for you. We call it the micro courses. Well, now you can study any subject, any chapter at your pace in a super fun and in a super interactive way. So, what are you waiting for? Just follow this link and enroll for any micro course that you want. Not just that, there are over 2,500 plus micro courses for your access, that too at a super affordable price. I'll see you in the session. Hey guys, welcome back to Vedantu's JEE channel guys. How are you all? कैसे हैं सब लोग? Guys, I'm sure you all are very geared up with all the sessions that we are doing for your JEE preparations for the month of April. Well guys, do tell me if you are preparing for JEE Main in the month of April in the comment box of this video. Okay guys, well this is the JEE Sprint and today's topic, as you can see it in the background, is about one of the most feared topics known as rotation motion. So guys, no need to worry. What we are going to do now, we are going to see a lot of questions, especially the questions which have come in JEE Main 2020 in the month of January. So you get an idea what type of questions to expect, what is the difficulty level, what is the length of solving a question as well. Okay guys, so let's go forward. So for all of you who do not know me, this is me, your Suri Sir, and fondly known as Mogambo on YouTube, because whenever you will be solving any question correctly with me, or you will be cracking the examination of JEE or NEET, to Mogambo khush hota hai. Yes guys, as you can see, I am an alumnus of IIT Bombay, and that's my Instagram handle. If you want, you can follow me as well. Don't worry, I'll not be posting anything related to physics over there. Okay, cool guys. So first thing first, what we are going to do now, I'm going to tell you that how the analysis of rotation motion was for the month of January when the JEE happened in the very beginning of this year. So let's have a look at that first. So guys, you can see that in rotation motion, all in all, every day a question was there. Such is the importance of this topic. You know that rotation motion is that topic which involves all the concepts that you have studied in any chapter before that. So entire mechanics actually can be summarized in this individual chapter. So that's why it's not surprising to see that every day questions were there. In fact, I would say surprising were the days of 8th and 9th of January, especially the second shift, when only a single question came from this particular chapter. Why? Because this chapter actually is the one where you can expect more than 2 questions to come, which happened only on 9th of January shift 1. So guys, all in all, if we'll count, we had 2, 3, 4 and 4, total 8 questions came in all 6 papers which happened in the month of January. We'll try to solve as many questions from the part of rotation motion, which are basically these questions which I'm going to take you forward to. Okay guys, before that, tell me if rotation motion is one of those chapters that you are not very confident about. Do tell me that in the comment box as well. Why? Because I have an amazing solution for all of you if you want to give it a very serious go before you appear for the JEE examination in the month of April, and consecutively after that in the month of May you'll be appearing for JEE Advanced as well. Yes, but for that, if there are still some chapters which you are not very good at, you don't feel very confident about, then guys, I have just the kind of solution which you require, and that is what we call as Vedantu's crash course. Let me take you through all the features of this batch which can benefit you a lot. So guys, obviously you get the live classes by the best of the teachers on the platform of Vedantu, including physics, chemistry and mathematics, all 3 subjects. And in this entire journey of preparation of JEE, you know what is the importance of appearing for test, especially the online one. So on Vedantu's platform, you get to appear for comprehensive test, you get to solve the assignments, and moreover, you get the detailed analysis of your performance. That is where you get to know where are your weak areas, which are your strong areas, and how exactly you are appearing in a paper, giving you the overall idea about your own performance. Okay. Apart from that, yes, when we are solving questions related to JEE, we come across doubt very now and often. So we all academic mentors, including me, are there to solve your doubts as well. If at all you ever miss out any live lecture, then you don't have to worry, because you can watch all the replays and recordings on the platform as well. Apart from that, you get the tips and tricks. You will be having rank booster quizzes and previous year paper analysis along with that. So guys, what do you have to do if you want to enroll for these courses? I'll tell you that as well. All you have to do is follow these links which are there in the description below. So when you follow this link, do not forget before enrolling to apply the coupon. What is the coupon that you have to use? It is SMCC. And what's the benefit that you get, guys? The course which is actually worth rupees 20,000, you can get it for just rupees 9,500. So do not miss out on the amazing opportunity which you have in front of you. You still have a lot of time left. So if you want to still strengthen your concepts in multiple chapters, then crash course is the thing for you. Okay guys, I hope I'm understandable. So let's go forward, and now let's have a look at the very first question. So what you see here is a question from obviously JEE 2020, which happened on the very first day, 7th of January. Looks like a question which is very conventional in rotation motion. Let's read that question first and then try to solve it. Question says that a block of mass m is suspended from a pulley in the form of circular disc of mass m and radius r. Okay, so what you see here is that mass of pulley and the block are same. Both of them have the same mass m, and the radius of the pulley is given as r. So the system, when it is released, obviously the block will start to move downward, will gain some kinetic energy. So we have to find out the angular velocity of the disk when the block has dropped by a height h. Okay, I hope the question is clear to all of you. When the system will be released from this particular position, what will happen? The block, while moving downward, will gain velocity, will gain kinetic energy. So when the block has fallen, say by a height h, it must have gained some velocity. So say it has gained some v velocity. Pulley also will start rotating, and when it is rotating, this is the pulley which will gain some angular velocity omega. Its radius is given as r. Okay guys, what we have to find out is the value of that omega, and our options are already here. Okay, I hope that you are already having a pen and paper with you and solving along with me when you are watching this video. Cool guys, so let's go forward and try to simplify this. As the question is asking about the angular velocity, and we know that if the body of the block is coming down by a height h, so its potential energy must be decreasing. So when its potential energy is decreasing, then certainly the kinetic energy must be increasing. But kinetic energy will not only increase for the block, but because the pulley is also rotating along with that, and no slipping is happening, so obviously it is also gaining the kinetic energy, with v being equal to omega r. Okay, because there is no slipping happening for the string over the pulley. Cool guys, so what I'm going to do, I'm going to use the law of conservation of energy. I'll say that the loss of potential energy will be equal to the gain in kinetic energy. Means what? Delta U should be equal to delta K. Okay guys, so when I write the loss in potential energy, there is only one object which is losing the potential energy, and that is the block, and that is mgh. Initial potential energy was considered to be say mgh, and final will be 0. So this is basically the amount of loss, and initial kinetic energy is 0, and final kinetic energy will be possessed by both the pulley as well as the block. Let me write that for the block. It will be going to be half mv square, and for the pulley it's going to be half I omega square. Okay guys, so now what? Because we are interested in calculating omega, so we'll have to convert this v by using v equal to omega r, and let's try to simplify that. So it looks like an easily doable question from here. So half m omega square r square, and if it is a pulley which is basically a disk, so the moment of inertia of a disk is half mr square into omega square. Okay guys, so now what? Let's try to find out the net value over here. It is m omega square r square, which is common. So this is half plus 1 by 4, that gives you 3 by 4 m omega square r square, and on the left hand side you have mgh. So what do you see? M gets cancelled from here, and if you rearrange, you get omega square, because that is what we are interested in finding. So we get 4gh divided by 3r square, which means what guys? From here, if you take the under root, then this r square will come out of the under root, and you will be left with under root of 4gh by 3, which on looking at the options, guys, tells us that option A, 1 upon r under root of 4gh by 3, is going to be our correct answer. Okay, so a very simple question, usually something which we all keep on solving in rotation motion. So I hope that you were also able to solve that along with me. Okay, cool guys, let's go forward. Let's have a look at the next question from here. So this is our next question, again from the same day, from next shift. This is 7th of January question, which says that for a thin uniform rod of mass m and length L, we have to find the radius of gyration for rotation about an axis passing through a point at a distance L by 4 from the center and perpendicular to the rod. So guys, we know that radius of gyration is comparison of any moment of inertia of any object with a point mass moving in a circle. So we say that the moment of inertia of that circular motion performing point mass should be equal to the moment of inertia of this body. So the radius in which that circular motion should happen, that radius is what we consider as the radius of gyration, which simply is m into k square, because for a point mass the moment of inertia is mr square. Here we are calling the radius to be radius of gyration, writing it as k. So first thing first, because it's a rod given to us, let's first think about finding the moment of inertia of this rod. And for that, let me draw the diagram of the rod first, how exactly they want us to represent it. So we have this rod, and usually this is where the center of mass for a uniform rod is. So if it is rotating about this axis of rotation, let's call this moment of inertia to be IC. And now, because you can see this is L by 2, so half of that will be L by 4 from where the present axis of rotation is present. So this is I, and this distance is mentioned as L by 4. Okay guys, so this is L by 4 from the center of the perpendicular, center and perpendicular to the rod, and about this axis of rotation we are interested in finding the moment of inertia, considering that the mass of the rod is m and the length is L. Okay guys, let's go ahead. So we know that for such cases when the axis of rotation has got shifted parallelly, then we use the parallel axis theorem, because one of the axis is passing through center of mass, and now it has been shifted by a distance L by 4, which we say is d. So how do we write the expression for parallel axis theorem? We say it is I equal to IC plus m d square. Okay guys, so what we can say that IC is basically moment of inertia of this rod when the axis of rotation was passing through the center of the rod, which is, I'm sure you are aware about this, is 1 upon 12 m L square. Okay, and if we have to write it capital L, then let's write it as capital L, because in options we see it as capital L, plus m, and what you see as d is L by 4 square. Okay guys, so now what, this was square, so 1 by 12 ml square plus m d square, which is L by 4 square. So now all I have to do is simplify this, and this is 1 by 4 square, that means it is ml square by 16. Means what guys, when you take the LCM of this thing, you'll be getting it as 7 by 48 ml square. That's the moment of inertia of this rod about the axis which is passing through this point, which is at a distance d from the center and perpendicular to the length of the rod. Now what? This is the moment of inertia that we compare with the circular motion performing mass, whose moment of inertia is mk square, where k is the radius of its circular path. So what do you see guys? M gets cancelled, and what we get the value as for k is under root of this, which is under root of 7 by 48, and outside is L. Okay, which looks like correct option to be option A. Okay, well, another very easily doable question. All you needed to know was parallel axis theorem and the concept of radius of gyration. Okay, cool. Let's go forward to the next question. So here's our next question. Now this one is a relatively lengthier question, because as you can see it from the diagram itself, what the question says, let's read that. The surface mass density of a disk of radius a, so that's basically the radius a which is given to us, and it is varying with the distance from the center of the disk as a plus b r square, with a and b being a constant. Okay, so we have to find out the moment of inertia of the disk when the axis of rotation is passing through the center and perpendicular to the plane of the disk. Means what? Right now the pen that I'm holding is basically the axis of rotation, and this is how the rotation is going to happen. So for that axis of rotation, we have to find out the moment of inertia. Now what you see here in the diagram already is the usual way of approaching any question in the case of rotation motion when you are dealing with a disk. You end up considering small rings which are making this entire disk. So we elementally choose a ring over here whose radius is r and its width is dr, though the radius of the disk is capital R, which is given to us as small a. So we are saying that when you start placing rings from the center till the periphery, starting from 0 to a, the entire disk should be made. This is how we usually find out the expression of moment of inertia of the disk with a uniform density, which comes out to be half mr square also. I hope you remember that derivation. You must have done that. Okay, so in this case also the approach is going to be the same, but the only difference is the surface mass density of the disk is not given to be as constant. As you are moving radially away, the amount of mass which is packed is increasing. The sigma value is telling us that the mass density is increasing. So for the same amount of area, more amount of mass is enclosed as you are moving away from the center of the disk. Okay guys, so let's try to find out the value of moment of inertia, and for that I have considered this ring whose circumference is going to be 2 pi small r and its width is given to be dr. That means what? If I will try to find out the small ring's mass, if the entire mass of the disk is capital M, then the ring has a mass that is dm. Let me just mention it over here. This is dm mass. So this dm mass is what we are trying to write down, because you know that sigma is defined as dm by dA, which is basically mass upon area. So dm should be equal to sigma into dA. But how will I write dA? For that ring, the area will be nothing but the circumference multiplied by the width of that ring. That means what? It is going to be 2 pi r into dr. So guys, this is the value of dm. Okay, now what? I have to find out the moment of inertia. So for the small ring, the moment of inertia will be written as dm into r square. That's how we calculate the moment of inertia. If I want to find out the moment of inertia of the entire disk, then I need to integrate. Okay, now what? We have to put this dm over here, which is basically 2 pi r, and this r square multiplies, so becomes r cube. And what is there? Sigma, will put that value in some time, and this is dr. So this is dm, which is 2 pi r into r square, makes it dr r cube. Then we have sigma, then we have dr. Okay guys, and what is sigma? Now I'm writing it here only guys, because of, you can see that I'll have to either rub, because it's going to be relatively a space taking derivation. So a plus br into dr. So I've just written the expression of sigma here. Now what guys? Just multiply this inside and do the integration. Integration limits obviously go from 0 to a. So we have 2 pi a into r cube dr plus 2 pi b into r to the power 4 dr, because there is one r multiplied with b. And what will you do? You will basically integrate, and integration limits are already known to you, that is 0 to a. Okay, so let's integrate that. So this is 2 pi a, r cube when you integrate is r to the power 4 by 4. If I will put the limits already, then this value, let me first complete the integration. This will be 2 pi b r to the power 5 by 5. Integration limits from 0 to a, which means I just need to put the value of a here to do the integration faster. Okay, so this is going to be a to the power 4, this is going to be a to the power 5. Now what do you see, guys? You see that 2 pi and a to the power 4 can be taken common. So 2 pi a to the power 4, if I take common, what I am left with inside is a to the power 4 is gone, so 4 is left. So here what you will write is a by 4 plus, over here 2 pi has gone out, a to the power 4 has gone out, so a is left, so you have b a by 5. So this is basically the moment of inertia of the disk. When we match with the options, guys, have a look. 2 pi a to the power 4, a by 4 plus ba by 5 looks like the correct answer is first option. Okay, guys, so you can see that this is what you used to do earlier also. The only difference was earlier this dm, when we used to write in terms of mass density and the area of that ring, mass density used to be constant. So we used to compare the mass density of the disk, m by a of disk, equal to the m by a of the ring. So it used to be a relatively much more smaller and simpler derivation and used to come out as mr square by 2. Okay, guys, I hope you understood, all of you. Okay, cool. So let's move on to the next question here. What you see here, guys, is the next question for us, which is from JEE 2020, 8th of January. Question reads that we have a rod. Yeah, so we have a rod of mass 4m. The rod mass is 4m and the length is capital L and it is hinged at the midpoint. Okay, so it's basically, if rotates, then rotates about the center only. That means moment of inertia is going to be 1 by 12 ml square, but m is 4m. Okay, so the ball of mass m, this one, is moving at 45 degree angle. This angle is given to you as 45 degree and with a velocity v, it is moving, whose components are already being given as v by root 2 and v by root 2, v cos theta and v sin theta. So this rod is going to hit, this ball is going to hit the rod, and the mass of the ball is also given to us as m. And what happens after that is that it sticks to the rod, and after that they both start to move together after the collision has happened. We have to find out the angular velocity of the combined system after the collision is done. I hope the question is clear. Rod is stationary initially, this ball is moving with a velocity v, it hits it here, and obviously only this part is what tells you that the momentum which is along this direction will experience a force. So only this component will be contributing towards the angular momentum. Okay, because v by root 2's angular momentum is going to be 0. Okay, guys, so now if we speak about the solution to find out the value of angular velocity after the collision, we will speak about the law of conservation of angular momentum, because whenever collisions are happening, I hope you remember that in the case of linear momentum case, when the bodies were linearly colliding, we used to conserve the linear momentum. When there is a possibility of rotation, we conserve the angular momentum. Okay, so let's go ahead and try to find out the answer of angular velocity of the combined mass. So if I try to write down that initial and final angular momentum are going to be same, so the initial angular momentum will only be possessed by this ball, and which angular momentum is what we are going to write down is with respect to v by root 2. Okay, because the angular momentum of v by root 2 in the horizontal direction is going to be 0, or you can also go by mvr sin theta, you will get the same thing. So I write that we get m v by root 2, this is the linear momentum in that direction, and it is from the axis of rotation, if you will see, is going to strike at a distance of L by 2. So let me write that, it is L by 2. If we speak about the final angular momentum, now the things have started rotating actually, which means what? If I write this as I omega, this was mvr, and then this is I omega. So for I omega, the moment of inertia is possessed by the rod, which is 1 by 12 ml square, but the mass is 4m. So 1 by 12 m into L square is the moment of inertia of the rod. And if I speak about the ball, then the moment of inertia for that is mass m, and L by 2 is the distance from axis of rotation, square that. So this is basically the overall moment of inertia multiplied by omega. So this is I and that is omega. Okay, guys, now what? Just we have to simplify it. So mvl by 2 root 2 should be equal to, from here what I see that this is going to be 1 by 3, this is going to be 1 by 4. So this is 4 ml square plus 3 ml square, that means 7 ml square by 12 times omega. That's what we are going to get. If I cancel out this 12 6 times here, what do I get? I can also cancel this m, I can cancel this l as well. So what do I have is v by root 2, and what do I have on the right hand side? I have 7l by 6 times omega. Okay, let's rearrange and simplify. So this rearranges to give me 6v. Yes, the options are in terms of v. So 6v by 7 root 2l is equal to omega. Okay, but if we look at the options, none of the options appear to be matching. But you know that you can write this 6 as what? As 3 into 2. Okay, means what? This is going to cancel with root 2, and what will be left in the numerator is root 2. That means omega will be 3 root 2 times v by 7l. Okay, cool guys. Now let's have a look at the options, and what we see that option A itself is matching, that is 7 root 2v by 7, 3 root 2v by 7l. That's the correct answer to this question, guys. I hope you were able to solve it along with me. Not even a lengthy question, that's easily doable. Okay, just you have to keep your concepts right here, and if this was the case, which if you appeared for this particular test, then I'm sure you must have solved this question easily. Okay, cool. Moving on, guys, next question. Now even more simpler according to me, looks like that. So what does the question say? A solid sphere of mass 500 grams is rolling without slipping on a horizontal surface. We have to find out the kinetic energy of the sphere if the velocity of the center of the mass is given as 5 centimeter per second. Only mistake which I can see people may make is not by taking the units correctly. Okay guys, again a question from 8th of January. Let's try to simplify this, because this is a very simple question according to me, and I'm sure you must be feeling the same, because all it is asking is to calculate the kinetic energy during pure rolling of the solid sphere. And solid sphere has moment of inertia passing through the axis when it is passing through the center of mass is 2 by 5 mr square. So when we write the kinetic energy here, obviously it will have kinetic energy due to translation, and it will have kinetic energy due to rotation. Okay guys, and we have to find out the value of kinetic energy only, and linear velocity is given. So obviously during rolling we'll be using omega as v by r. Okay, so we'll be putting this over here. So we have half mv square plus half, this is 2 by 5 mr square, and omega can be written as v by r. So omega square is v square by r square, so r square gets cancelled. So what do I have, guys, here? I have this cancelling with this, so I have 1 by 2 mv square plus 1 by 5 mv square. So what do I get out of it? By taking LCM, this is 5 plus 2, that means 7 by 10 mv square. Okay, so that comes out to be the kinetic energy. All I have to do now is to put the value of mass and the speed. So let's do that. 7 by 10, mass is 500 grams, let's write it as half a kg, and velocity is 5 centimeters per second, which means what? It is 5 into 10 to the power minus 2 meters per second, and when you will square it, it will come out to be 25 into 10 to the power minus 4. Okay, so what next? Let's just simplify this. This cancels 5 times by 5, this cancels 2 times by 5. So what do I get? I get 7 5s are 35 divided by 4, so 35 by 4 into 10 to the power minus 4. Okay, that's what we get, and looks like answer is in joules, and option B looks like correct to me. Okay, cool guys, even simpler than the previous one. I would say free K marks. Okay, cool guys, let's go ahead. Okay, now let's read the question first, because it could be disk, it could be sphere, It could be rings also. Let's see. Question says that three identical solid spheres, each having mass m and diameter is d, they are touching each other as shown in the figure. We have to calculate the ratio of moment of inertia about an axis that is perpendicular to the plane. That means an axis that is coming towards you, and those are 2 points about which we have to find that. One is P, other is B. So about these 2 points we'll have to find out the moment of inertia, and we have to find out the value of the ratio of moment of inertia about P to B. Okay, so as you can see, appears like, because we'll have to apply the parallel axis theorem again here, because the one that we know is about A, B and C for individual spheres, which is 2 by 5 mr square. But now the axis of rotation has shifted to P as well as to B, so that's why we'll have to apply the parallel axis theorem. So could be a little lengthy as well, but we'll have to keep our mind in the question. We don't have to be distracted when we are solving this question, because such questions are prone to making only silly mistakes because they have nothing extraordinary in terms of thought process. Okay guys, so let's try to solve that, and we'll try to find out the ratio of the moment of inertia for P and to B. First thing first, because the triangle ABC that you see here will be an equilateral triangle whose side length is D. So when you will try to find out the value of, say, this length, which is basically the distance by which your axis of rotation has shifted from here to here, you know that this value, if I call it x, it will come out to be d by root 3. Okay, properties of equilateral triangle. Okay, now what? Let's try to find out the moment of inertia about point P, which is same for all the spheres, because that is symmetrically placed point for all the three spheres here. So if I try to find out the moment of inertia about P, I'll just try to find that out for one of the spheres, and I'll just multiply it by 3. So if I take it 3 times the moment of inertia, so it's going to be ICM plus mx square, because x is the distance by which your axis of rotation has got shifted for all the three spheres. Okay, so this is 3. Moment of inertia about center of mass for a solid sphere is 2 by 5. They're using small m, so small m r square plus, even let's do one thing, instead of writing it as capital R, you can see that the radius is going to be d by 2. Okay, so when I square that, I'll be getting it as d square by 4. Okay, so 2 by 5 m r square is what I'm writing, but r is equal to d by 2. Okay, so this is the moment of inertia about center of mass into m, and what is x? X is d by root 3, that means d square by 3. Okay, so what? This cancels it 2 times, so this is md square by 10 plus md square by 3. So when we take the LCM, we get it as 3 plus 10 by 10 into 3, that is 30 times md square. And when you will do the calculation, simplify this, numerator is 13, denominator is 30 by 3, or simply 10. So what we get, the moment of inertia about P as 13 by 10 md square. Let's have a look at the options. Okay, A or D may have the correct answer. Okay, don't take a call yet. Even if there would be only one option, don't say that that is going to be the option with 13 as written in the numerator. Anything is possible with mathematics. Cool guys, so what I'm going to do now, I'm going to just write down the value of moment of inertia about P here, which turned out to be 13 by 10 md square. Okay, and now I'll try to find out the moment of inertia about the other axis of rotation, which will pass through B. Now you know that for this sphere, the axis of rotation is passing through the center of mass, but when we speak about A and C, the axis of rotation has got shifted by a distance d. So for A and C, you'll have to apply theorem of parallel axis, but for B, you don't have to. Okay, so let me try to find the value of IB now. So that is going to be 2 by 5 mr square for the first sphere. So that is 2 by 5 m. R value we wrote it here as d by 2. So squaring that will give you d square by 4. So that's the moment of inertia of that sphere whose center is B. And for the other two spheres, I'll write for one of them and just double that value, because those are again symmetrically placed with respect to point B. So for that, ICM is 2 by 5 mr square. So R value is d by 2. So this is what we get, plus how much is the gap between the two axes? This is where B is, this is where we wanted it to be. So d distance gives you md square. Is that clear? Moment of inertia of the sphere whose center is B. This is twice the moment of inertia for basically adding moment of inertia of A and C, which is moment of inertia about center of mass plus md square. And this d is basically the distance between the center of mass of A or B with point B. Okay, so let's try to simplify. What we get here is md square by 10, because this 2 cancels this 4 2 times, plus same things happen here. We get this as 1 by 10, and 1 by 10 plus 1 gives me 11 by 10 md square, which means what? I get md square plus 22 md square, that means 23 by 10 md square is what I get as IB. Okay guys, so now what we have is IB. We already had found IP, so IP by IB, as you can see, md square is common, 10 gets cancelled, md square gets cancelled, we get 13 by 23 as our correct answer, which is option A, 13 by 23. Okay, so this was question which came on 9th of January in JEE Main 2020. Okay guys, so as you can see, this was a lengthy question, but not very difficult, but not actually, you cannot put it in easy category also. It is above medium, but touching almost the difficulty level of a difficult question. Okay, cool guys, let's go forward. So now this question which you see is also from the 9th of January, shift 1 or 2, I don't remember exactly, but one of those shift. But the question says that a rod of length 1 meter is released from rest, as you can see it in the screen, and if omega of the rod is under root n at the moment when it is about to hit the ground. So when the rod will be about to hit the ground, say the angular velocity comes out to be under root n. So we have to talk about the value of n. So it's the integer or numerical type of question. So when the rod will come here about to hit the ground, obviously it will be gaining some angular velocity by that time. So if it has got by that time some angular velocity of omega, we have to find that out. Now because it is a pure rotation, because it's a pure rotation case, because it is hinged from one of the ends, and in that case the body can only gain rotational kinetic energy. So what we will try to think of is not from laws of motion, but from work per energy point of view, that whatever is the loss of potential energy of the rod should convert into the rotational kinetic energy. Okay, so guys, let's see that somewhere over here is the center of mass. So if we try to talk about its height, you know that this is going to be half a meter and this angle is 30 degree. So this is going to be half cos 30 degree, and cos 30 degree is root 3 by 2. So this is root 3 by 4. Okay, so this is going to be sine. This thing is half cos 30 degree. This is going to be half sine 30 degree, and sine 30 is half. So this is going to be 1 by 4 of the length. So this is 1 by 4 meters. And now we'll try to apply law of conservation of energy. So whatever is the loss of potential energy mgh should be equal to the gain in kinetic energy, that is half I omega square. Okay, so the mass of the rod has not been given, so let's keep it as m. G value, still not putting it as 10 yet. H is 1 by 4 and this is half. Moment of inertia for the rod when the axis is passing through the end of the rod is not 1 by 12 but 1 by 3 m L square, but the length is given to be 1, and then multiply that by omega square. So this is half I omega square. Okay, now what? You can see that M appears to be getting cancelled. This 2 is cancelling 4 2 times. So on the left hand side I have G by 2, and on right hand side I have omega square by 3, which means omega square comes out to be 3G by 2, which if I say that G value, if nothing is mentioned, I will assume it to be 10. So this value comes out to be 15. Means what? If omega square is 15, omega should be equal to under root 15. Means what? N value is 15. The value of N is going to be 15. That was the answer to this question. Okay, simple application of law of conservation of energy. Okay guys, so in the beginning only I told you that whenever we are solving any questions from rotation motion, this particular chapter can involve concepts starting from vectors, motion in 1D, motion in 2D, laws of motion, friction, or work per energy, or center of mass of collision. Everything that you have studied before rotation gets utilized over here, and that is why rotation is one of the most favorite topics of examiners in JEE, because just by asking a single question from this chapter, they can test you in multiple concepts. Okay guys, I hope that these questions are helpful to you so far. Okay, so yes, there is one question for all of you to try as well. So this is your homework question guys, have a look. I'll just get aside for some time so that you can take a screenshot, understand the question. So looks like something which we are very commonly habitual of solving. You have a system of a pulley which has moment of inertia as I, and the blocks are of mass m1 and m2. So the question says that if block m1 falls by h height, given that m1 is greater than m2, and assuming that there is no slipping happening here, that means kind of pure rolling type of situation, then what we have to find out is the angular speed of the pulley. So you have to find out with what angular speed the pulley will be rotating when the block m1 has come down by height h, and obviously m2 must have gone by the same height above. Okay guys, so that's your question. Question is from JEE 2020, 9th of January. Okay, I hope that you guys enjoyed solving questions along with me. You must have felt good about the questions which came in the month of January, because it gives you a feeling that when you will be appearing for the JEE Main in the month of April, you will get almost the similar type of questions and you will be able to crack all these questions. Okay guys, so if you enjoyed the session, if you liked the session, then do not forget to hit that like button below this video. And if you haven't subscribed to our channel, then do subscribe. And if you think that these videos are helpful, the sessions which we are conducting for all of you, for all physics, chemistry and maths chapters that we are doing with you, then do share with your friends as well. Okay guys, so I'll see you guys again with another chapter. We'll solve another chapter's question, especially from JEE Main 2020 of the month of January. Till then, keep studying, keep smiling, and keep enjoying physics. Bye-bye.